Hello guys, this is Jastily Polymath with you here again, and today we have a very quick one. You're welcome, and it's been a while, isn't it? Often a while. It is. So, without wasting much of our time, I would like us to go into this particular problem which I've seen, and let's discuss it. Okay. All right, guys. So this is it. Um, the question is, rather, what I'd say comes from vectors, and we're going to see how much we would be able to do with it. And they said the resultant of two forces, 12 Newton and 5 Newton, is 13 Newton. What is the angle between the two forces? There are certain things you have to know before you're able to solve problems like this. I would first recommend that you know the parallelogram laws of vectors, which state that the parallelogram law of vector okay, they said if two vectors are represented as adjacent sides of a parallelogram, then their resultant is represented by the diagonal of the parallelogram starting from the same point. Okay, so what this is literally trying to say is that if you have two vectors, say here and here, I could mark them and I could mark them. Let me call here A and then here B. So if we have two vectors, say A and B, we acting at an angle to each other, you find out that using the parallelogram laws of vectors, the resultant has to come as some sort of diagonal springing up in between it. And just like you can see in this diagram, and then the only way you can resolve problems like this is acknowledging the symmetry of the diagram, acknowledging the fact that this side can be reflected here and then this side can be reflected here to create a parallelogram, of which you can use the principles or the concepts of parallelogram to solve these problems on the vectors. So now, having that knowledge, you also have to get yourself acquainted with the cosine rules, of which is not a big deal. And provided you have questions and you don't understand these things I've aforementioned, it's fine. You can still subscribe to my channel and probably reach out to me through the following means that will be outlined later so that I can guide you through if you're having physics or math problems, even for the mathematics for first year students. So um, this is it. We have to also acknowledge that the sum of interior angles of every quadrilateral, such as a parallelogram, is equal to 360. So that is that. Now, having established these background concepts, let us now talk about the question: how do we apply this background knowledge to the questions that is given? So let's dive right in. So they said the resultant of two vectors, two forces. So I'm going to okay, solution. So I'm saying two vectors. If these two vectors are acting at an angle to each other, one has to be longer than the other because one is 12 Newton and the other is 5 Newton. So we have here to be 5 and here is 12 Newton. And as the case may be, using the parallelogram laws of vectors, we know that the resultant has to come from here. But before that, we have to also draw a diagram for this, which means I would say this. I'm kind of representing this in a parallelogram, which means we're going to have something like this. And then I'm creating some sort of reflection. Okay, this is pretty bad. Sorry. Okay, so, okay. I'm not positioned well to doing this, but you should get the point. is looking like a parallelogram now, and of which the resultant has to come from here and meets at this point. That is the idea. So now that we've established this concept, I'd have you know that if here is 5 Newton, here would also be 5 Newton due to the fact that opposite sides of a parallelogram are often equal. Sorry about that. Okay. So here happens to be 5 Newton, and then here would be 12 Newton. Basic knowledge we already should know. We should know already that we have two triangles here. We are going to take one of these triangles and make something out of it. That would mean, remember the resultant was said to be 13 Newton. In other words, the resultant here happens to be 13 Newton, and we're going to use that. So let me redraw the diagram. We have so many diagrams to redraw here. Happens to be the longer one. It should be the so here is 12 Newton. It might not be looking like much like the previous one, of which is not run to scale. So we have 13 Newton. Now, in the light of that, I could say, all right, no problem. Having our resultant here R, and then these component forces F1 and F2. I can say, all right, using the cosine rule, because I need to find the angle relative to the resultant, something here. That's the only way. So if I'm going to do that, finding the angle opposite to the resultant, if I'm going to do that, I'm using the cosine rule, of which I've shown you in the previous board. That means we would have here r squared is equal to 12 raised to the power of 2. Sorry, I just have to plug in values directly. So that means 13 squared plus 5 raised to the power of 2. Oh, today is a clumsy day for me, I guess. So minus 2 times 12 times 5 cos an angle we do not know. Let's call it theta. So that would mean making cosine subject to the formula, because that's necessarily what we have to do. Firstly, we have to obtain our values, but I wouldn't do that until we make it properly the subject of the formula. So that means I would have here 13 raised to the power of 2 equal to, okay, that's not necessary. Okay, so I'm going to have here 13 raised to the power of 2, subtracting 12 from both sides, 12 raised to the power of 2 from both sides, then subtracting 5 to the power of 2 from both sides. So, and then we also would have to divide through by 2 times 2 times 12 would give us 24. 24 times 5 would give us 120. So I'm looking at negative 120. So I have negative 120, of which we're going to be dividing through by negative 120. That would be negative 120 equal to cos theta. Provided this doesn't make any sense to you, it's fine. You get? I'm just trying to speeding up the process here. So let's jump over to our calculator to see how much help we can get from there. Okay, a quick one. 13 to the power of 2, which is 13 raised to the power of 2 That's about 169. So I can write that down. 169. And then 12 raised to the power of 2 would be about 144 minus 25. All right, back to our board. So all over negative 120. Remember, all of this is equal to cos theta. Now we have to resolve further what this would be. So let's go back to our calculator. So we'll be having 169. All right, let me clear out first. So 169 minus 144 minus 25. That'll give us 0. How is that possible? Clearly, I get the point. I feel like 0. How is that? And of which it is. Okay, let's revisit that question one more time. So we have every of these things here happen to be 0. So we're looking at 0 divided by negative 120. That would give us 0. I'm not going to quit because I know that cos. Okay, so we have here cos theta. So we're going to find what the theta is, the angle. So we have theta is equal to the cos inverse of 0, which undoubtedly is equal to, what should that be? 90 degrees. So cos inverse of 0 is equal to 90 degrees. In other words, the angle opposite to the resultant is 90 degrees. Now, before we conclude everything here, I want to put it to you that provided at this point we have a resultant stretching out into this place, you must understand that here happens to be 12 Newton and here happens to be 5 Newton. So if here is 12 Newton and there 5 Newton, you should also agree with me that we have B, angle B to be equal to 90 degrees. And one thing about parallelograms is that the opposite angles are equal. So if here happens to be 90 degree, here would also be 90 degree. So that would mean 90 plus 90 would be about 180. Since the sum of interior angles of every quadrilateral is 360, that means the angle between here and here are going to be equal. And that would be also 90. That means our answer for this problem is this. All right, I hope you did understand what we've done here today. Provided you have more questions, you could always reach out to me and I'm always happy to help. So I'll be seeing you in my next video. Special thanks to everyone who has made this content creation a thing and a success. I'm deeply indebted, and you can always reach out to me using the following medium that is outlined there. So I'll be seeing you soon. Have a happy week. Bye.